Chapter 10.5, apply other angle relationships in circles. Okay, you know that the measure of an inscribed angle is half the measure of its intercepted arc. This is true even if one side of the angle is tangent to the circle. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. All right, so this line here is tangent to the circle because it intersects the circle at one point, point A, and this right here is a chord. Okay, that's a segment whose endpoints are on the circle itself. So this right here is angle 1, and that equals half of the measure of arc AB. So this right here is arc AB. So that means if we let the measure of arc AB equal x, so let this be x degrees, then that means angle 1 is going to be 1/2 of x. So right here, that angle 1 is just half of x. So the angle is half of the arc. All right, and the same is true on the other side. This arc here in blue, that is intercepted by angle 2. All right, and angle 2 equals 1/2 the measure of arc BCA. So that's this arc here in blue. So again, we can let the measure of arc BCA equal x degrees. All right, and angle 2 is going to be half of x degrees. So once again, the angle is just half of the arc. So that's for a tangent meeting a chord. Example 1, line M is tangent. Find the measure of the red angle or arc. All right, so right here, we see the red angle, that's angle 1. And we said a minute ago that the angle is half of the arc. So that means the measure of angle 1 is just going to be half of this arc right here that runs from A along the circle to point B. That arc is 130 degrees. So half of 130 is just 65. All right, part B, once again, we have the angle right here. This is 125 degrees. We're looking for the measure of this arc here in red. It goes along the circle from K to J and all the way around to point L. All right. So the angle is half of the arc. So I will say angle L, the measure of angle L is going to be 1/2 the measure of KJL. So you need to use 3 letters when the arc is more than half of the circle. Now, we don't have KJL, so we're not taking half of anything. I am going to start off by multiplying both sides by 2. All right, the opposite of times 1/2 is times 2. So I'm just going to take both sides, the whole thing, and multiply both sides by 2. And of course, 2 times 1/2 cancels because 2 divided by 2 is just 1. 2 times the measure of angle L is going to be 2. And the measure of angle L is 125. And that equals the measure of arc KJL. And 2 times 125 is just 250. And that is in degrees. Okay, please try guided practice number 1. You're looking for the measure of angle 1. All right, angle 1 is right here. This angle right here. We have the tangent, we have the chord, so we know the angle is going to be half of the arc. The arc runs from this point along the circle to this point over here. That's 210. We know the angle is just going to be 1/2 of 210. All right, the angle is half of the arc. And of course, that is just 105. All right, please try number 2. We're looking for the measure of arc RST. So that's going to run from R to S to T. Please try it. All right, here's the angle right here. And we know that the angle is half of the arc. Okay, so angle T is going to equal 1/2 of the arc. So that's RST. It's actually the measure of RST. All right, and like I said, you can plug in numbers if you want. I'll do it that way for now. Okay, before I multiplied both sides by 2, but right now for the measure of angle T, that's just going to be 98. And that equals 1/2 the measure of RST. Okay, the way to get rid of 1/2 is just to multiply both sides by 2. 2 times 98 is 196. And 1/2 times 2 cancels. We're left with the measure of arc RST. All right, and that's in degrees. So you can multiply both sides by 2 before you put in the numbers or after. All right, last one. We're looking for the measure of arc XY. Okay, so that goes from point X along the circle to point Y. Okay, when there's 2 letters, you go the shorter way around, not the longer way around. So this right here is the angle. We said the angle is half of the arc. So without even writing the algebra, without even writing the letter equation first, I'm going to just plug in 80. We know that 80 equals 1/2 of that arc, so it's the measure of XY. All right, and once again, just multiply both sides by 2. 2 times 80 is 160. 1/2 times 2 drops out, and we're left with the measure of arc XY in degrees. If 2 lines intersect a circle, there are 3 places where the lines can intersect. Okay, so right here, they intersect on the circle. Right here, they intersect inside the circle. And right here, they intersect outside the circle. If 2 chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. All right, so let's look at the measure of angle 1 first. Angle 1 is this angle right here. Okay, and we can see these 2 chords. They make the X shape because they intersect inside the circle. So the X shape forms vertical angles. So this angle right here matches angle 1. All right, and we look at the arcs for each of those angles, and we take half of that. So the arc for angle 1 runs from D to C. All right, we got that right there. And then the arc, this angle is not numbered. This is 2 right here. This angle is not numbered. This angle's arc runs from A to B. All right, and that measurement is right there. So you just add them and you take half or divide by 2. Okay, it's the same as finding the average. All right, so when the 2 chords intersect inside the circle, if you want to find a measure of one of those angles, you just take the average of the arc that it intercepts and the arc that its vertical angle intercepts. All right, and let's see. We see the same scenario with the measure of angle 2. Okay, angle 2 is this one right here. And we see the vertical lines. Once again, these chords, they make vertical angles. So this is angle 2. This one right here is congruent to angle 2. But the arcs are not necessarily congruent. Okay, but this is its vertical angle. So the original arc for angle 2, that runs from B to C. And we have that right there. The vertical angle, the arc, runs from A to D. And we have that right there. Okay, we're just taking half of the sum. Okay, so once again, it is the same as finding the average. Now for the ones outside the circle. If a tangent and a secant, 2 tangents or 2 secants intersect outside a circle, the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. All right, so this line right here hits the circle twice. Okay, so that one is called a secant. And we already know this one down here, it hits the circle once. That one is the tangent. All right, so if you look at angle 1, and they intersect outside the circle, what you do is subtract the intercepted arcs. So we see the smaller arc right here in blue, and we see the larger arc right here in red. All right, so we subtract the one in red minus the one in blue and take half of that, and that's going to equal the measure of angle 1. All right, the next example, it's the same formula, but now we have a tangent line and another tangent line or ray. All right, they intersect outside the circle. So once again, you take the intercepted arcs. Okay, you take the larger arc right here in red. That's right there. And then you take the smaller intercepted arc right there in blue. That's right there. You subtract them and you take 1/2. And that will give you the measure of angle 2. Okay, of course, when you subtract, you're putting the larger arc measure first. Otherwise, it's going to be negative. Third and final case, see this intersects the circle at 2 points. That is a secant. And down here as well, that is a secant. Okay, and if you look at the measure of angle 3, the smaller arc is right here in blue. The larger arc is right here in red. All right, so you take the larger arc, you subtract the smaller arc, and you take 1/2. So this is for when the lines intersect outside of the circle. We can see that in all 3 cases. You take half of the difference of the arcs. Example 2, find the value of x. All right, so we're looking for this angle right here. Now these points intersect inside the circle. These chords make vertical angles. All right, so we're also looking at this angle here. And we just go to the intercepted arcs. All right, so this angle X intercepts that arc. Okay, that's 156. And this angle here intercepts that arc. That's 130. We said when they intersect inside the circle, we just take the average. So we're going to add 156 plus 130 and divide by 2. Same thing as multiplying by a half. Okay, this is 286 divided by 2, and that is going to equal 143 degrees. That's angle X. So remember, when they intersect inside the circle, you add and divide by 2. Example 3, find the value of X. All right, now here it intersects outside the circle. All right, we're looking for this angle X right here. We see the arcs. The smaller one is right here, runs from D to B. The larger one, I'll do it in a different color, runs from A to point D. All right, so when the lines intersect outside the circle, we look at the intercepted arcs and we subtract and take 1/2 or divide by 2. So put the larger one first, that's going to be a 178. And I'm going to subtract 76 and take half of that, or just divide by 2, same thing. Okay, and this is going to be 102 divided by 2, and that equals 51 degrees. And that is angle X. All right, please pause and try number 4. And I'll give you a hint right here. You need to get this angle right here. Okay, and this is a straight line, so you're going to have to subtract 102 from 180 to get that angle. All right, we have a straight line right here from B to D. So the whole thing from there to there is 180 degrees. So that means this angle right here, that's just going to be 180 minus 102. So that is just 78. All right. And now if I can erase some of this mess here, we know that when the lines intersect inside the circle, you have to take the sum of the arcs that are intercepted. You also have to look at the vertical angle. So this X shape right here, those two red lines, they make vertical angles. So we have to look at this angle and that angle right there. Okay, we don't need the value of that, but we have to look at the respective arcs. So if you take the 78 and go to its arc, I'll do it in a different color. If you take the 78 angle, 78 degrees, and you go to its arc, that runs from D to C, and that arc is 95. And if you take the vertical angle and go to its arc, it runs from A to B, that arc is Y. So we said you add them and divide by 2. And that's going to equal the angle, which is 78. Now, what's the opposite of dividing by 2? You have to multiply both sides by 2. Okay, 2 divided by 2, that just cancels. And we're left with 95 plus y. 78 times 2 is 156. Solving for y, the opposite of positive 95 is negative 95, and it cancels. Bring down your y. 6 minus 5 is 1. 15 minus 9 is 6. And that is in degrees. If you want to double check, just do 61 plus 95. That's 156. And then 156 divided by 2 will give you 78. So it checks out. Okay, please try number 5. And remember, when it intersects outside the circle, you're subtracting the arcs. Okay, so the rays or lines that intersect outside the circle. So this angle here is 30 degrees. And it intercepts this arc right here, which is 44. And this arc right here, which is A. All right. So we're subtracting A minus 44. And we need to take half of that, or divide by 2. And that is going to equal the angle formed outside of the circle. All right. Now, we have divided by 2. The opposite of dividing by 2 is times 2. Do that to both sides. 2 times 30 is 60. 2 divided by 2 cancels, and we're left with A minus 44. The opposite of negative 44 is positive 44. Cancels here. 60 minus 44 is 16. And bring down the A. So A is 16 degrees. And that can't be correct. So let's see. I'm sorry, 60. I subtracted. Supposed to add. 0 plus 4 is 4. And 6 plus 4 is 10. And that's in degrees, and that makes sense. Here's 44, this is 104.